All right, here are your solutions. You should have tried it first and check in your answers or if you get stuck. So first, limits. I don't know why this starts with number 4. I'll be honest. I just recognize that now. Start with number 4. All right, limit as x approaches infinity. That's a end behavior question. So we're looking at the power terms. So if I just look at the power terms, the power term in the numerator is 3x cubed and negative 5x cubed. The x cubes cross out, and there's your answer. The next question, the limit as x approaches 2 from the right. Now, if I plug in 2, whether from the right or from the left, the same answer is going to happen. 2 take away 2 is 0 divided by 5. Now, if I look at this one actually is an asymptote at 2, so I have to think to the right of 2, is it going to infinity or negative infinity? So if I plug in a number bigger than 2, like 3 or 4 or 5, I want you to notice the answer is negative. So to the right of 2, it's actually going to negative infinity, and to the left, it's going to positive. So to the right, plug in a number bigger than 2, and see if the answer is positive or negative. Here we have a limit as x approaches 0. This is piecewise. This part doesn't matter at all. So I need to know from the left and from the right, is it the same answer? So if I plug in 0, the answer is 1. If I plug in 0, the answer is 1. That's what matters. Because they match, that's the answer. When looking off a graph, the limit as x approaches 1. So look where 1 is. If I look from the left and right, they both are approaching the y-coordinate 2. A limit consists at a whole. The limit as x approaches 2, notice again from the left and from the right, it's the same answer, and it's the y-coordinate, which is negative 1. So if it's a removable whole like that, and if I go from both directions and it gives you the same y-coordinate, that's the answer. Again, I'm going from number 9 to number 11. There's no reason. Here we go. The average rate of change of a function is AROC. So first, before I go much further, the y-coordinate. So if I plug in the y-coordinate, oh, it's already done for me. So like I have the point. So the y-coordinates are there. So the 2 y-coordinates, the 2 x's, and then you solve it. You don't need to simplify it. If I want to know the instantaneous rate of change at a point, I have to take the derivative. So first, I'm going to make it friendly, and then I'm going to take the derivative. So the derivative here is 1/2, subtract 1 to the exponent, and then I need to remember the hook. And then I plug in only the x coordinate. I only need the x, which is 1, both are 1, and then solve it. There's a 2 in there. 1/2 times 2 is 1. It actually ends up being positive 1 to the negative half, and 1 to any exponent. The answer is 1. All right, find the x values where we have horizontal tangents. And so I need to understand that tangent, that's slope, that's derivative, and the slope of a horizontal line is 0. So what it's asking is take the derivative. I can do that. That's 4x cubed minus 32x. Make it equal to 0. That's the horizontal part. And then solve it. So we can factor out a 4x. And one answer is 0. For the second one, there are answers. They're just irrational. So if I make it equal to 0 and add 8, the answer is both positive and negative. You don't need to simplify it. But the answers are 0 and positive and negative root 8. All right, find the equation of a normal line to this. So we're going to do this. For a line, we need to know the x and y coordinate. The x is negative 1. To find the y, you plug in negative 1 and solve it. So that is negative 1 plus 4. That's 3. And then the slope, I need to do the derivative. So we have the derivative, which is 3x squared minus 1. And I'm going to plug negative 1 in and solve it. But then I need to do something. So I plugged negative 1 into the slope and got my answer. Now for the tangent line, it would be that slope. But for normal, I have to do the opposite reciprocal. So I need to go negative 1/2, then it's x plus 1, and then plus 3. Who knows? What's the next question? 28 or something? 14. Can you take the derivative implicitly? So we need to remember when we take the derivative and y is involved, we need the hook y prime. So this is the product rule. X and y squared is the product rule. That's the first times the derivative of the second with the hook plus the second times the derivative of the first. The derivative of negative x is negative 1. The derivative of 2y is 2, but it needs the hook y prime. And the derivative of 5 is 0. So if you need to practice that once or twice or 3, do it. Then I'm going to factor out a y prime. So if I factor out a y prime here, that's 2xy. If I factor out here, that's plus 2. And everything else, I'm going to move to the other side. So positive y squared becomes negative y squared. This becomes plus 1 on the other side. And then I divide and I have my answer. Or it doesn't matter. It could be 1 minus y squared or that. A rectangle is bounded here with this equation shown on the right. What's the area of the rectangle having a maximum area? So the area of that rectangle, and I want you to show the x coordinate here, would actually be 2x times y. That's the area. 2x's times y, which is the height. I know what y equals. So it's right there in the equation. So y is equal to 5 minus x to the 4th. So take out the y and plug in what y is. Distribute. That's going to be 10x minus 2x to the 5th. Then I'm going to take the derivative, which is 10 subtract minus 10x to the 4th. And then I'm going to make it equal to 0 and solve it. So I'm going to add 10x to the 4th, divide by 10. The 4th root, that answer is going to be 1. That solves that equation. If I did a number line here with 1, if I plugged in negative 1/2, the answer would be positive. If I plug in like 2 or 3, it's negative. That creates a maximum, which is what I wanted in terms of the derivative. And it says, what is the area of the rectangle? So the x value is 1. To find the y value, I go back in here and plug in 1 for x. So it's 5 subtract 1 to the 4th. That's 4. And that means the area is 1 times 4, which is 4. Actually, it's 2x, right? So let's do it right. So 2 times 1 times 4, which is 8. So back in here, so the x value is 1, the y value is 4, and then you plug it into the area formula, and that gives you the area, which is 8. All right, we have an equation, and so underneath we're going to do some work to understand increasing, decreasing, and concavity. So first, I'm going to take the derivative. That's 6x squared minus 6x. Make it equal to 0, and I'm going to solve it. So I'm going to factor out a 6x, and then I have my answers. I'm going to draw a number line with 0 and 1 into the derivative. If I plug in a negative number, the answer is positive. If I plug in 1/2, and if I plug in a number bigger than 1. So you can take your time and see. All I care is if the answer is positive or negative in the interval. And so I can see, well, first of all, it's increasing from negative infinity to 0 and from 1 to infinity. It's decreasing from 0 to 1. I know there's a maximum at 0, and if I plug 0 into the function, 0 and 0, I got 6. I know there's a minimum at 1, and if I plug 1 in for x, I get 2, take away 3 plus 6. That's 5. Point of inflection concavity, that's the second derivative. So take the derivative of the first derivative, 2 times 6, and make it equal to 0 and solve it. So I'm going to add 6 and divide by 12. That's 1/2. Again, I'm going to draw a number line for 1/2. If I plug in 0, the answer is negative. If I plug in 10 or 20 or 30, it's positive. So there's a point of inflection here. So it's concave up, first of all, from 1/2 to infinity. And it's concave down from negative infinity to 1/2. And we have a point of inflection at 1/2. Oh, I don't really want to do that. But anyways, you would plug 1/2 in for x and solve it to find it. So I'm going to cheat and just call it that. And I'll be done with that. A quick way to get it done. All right, turn the page. I'm not worried about it. And on the final exam, I'm not giving you a fraction to work out like that. Okay. Next one. Hey, 18. It's following like an order now. Can you integrate? So to integrate, we're going to add 1 to the exponent and divide. We're going to add 1 to the exponent and divide. Negative 1 is negative x. And make sure you include the constant. Sometimes you have to write it friendly. So that's 2 minus 3x to the negative 2. That's negative 3. So that becomes negative 1/3. So what it was over what it became. Negative 3 is not part of the answer. So it's negative 1/3. Then 2 minus 3x. Add 1 to the exponent and divide. You might have seen this on the exam before. This one I'm going to simplify. So I'm going to write it as 3 fractions. And then write it friendly from there. So x squared belongs to all of them. So x cubed divided by x squared, subtract the exponents. X squares cross out, that's 2. 1 over x squared is x to the negative 2. We haven't integrated yet, but we will now. So x will be x squared over 2. Negative 2 is negative 2x. Add 1 to the exponent and divide. And then don't forget the constant. These are definite integrals that have bounds. So from negative 1 to 8, write it friendly. That's to the exponent 1/3. So again, we're going to add 1 to the exponent. I like doing the reciprocal, or you could divide by 4/3. And then negative 1 to 8. So then we plug in 8 first, subtract, then plug in negative 1, and you have your answer. Here, this is a graphing question. So we're going to graph this from 7 to 1. So what makes it 0 is 3. Then we have 4, 5, 6, 7. So from 1 to 7. So if I plug in 1, the answer is 2. We have 3 here. So that's one triangle. And then if I plug in 7, the answer is 4. So I have 7 and I have 4. There's the other triangle. And so I want to find the area of each one of these and add them up. So the first triangle, it's 1/2. The base is 2 and the height is 2, plus the second triangle. The base is 4 and the height is 4. And you don't need to simplify it. Function has a derivative. Find the function if its graph passes through a point. So to find this, I'm going to integrate that derivative. And that gives me 6x squared divided by 2 minus 5x plus c. Then I'm going to plug in 2 for x. And make it equal to 6. And then I'm going to solve to see what c equals. So 6 divided by 2, this is really 3 times 4, which is 12. 5 times 2 is 10. Just work until you get the answer. And the answer at the end when you solve it is 4. So the final answer then would be f at x equals, now I'm going to go 6 divided by 2, so I'm going to go 3x squared minus 5x, and then our c value is 4. Can we sketch? So we have x squared subtract 2. That's here. I like actually using real points. So 1 gives me negative 1, and negative 1 gives me negative 1. 2 gives me 2, and negative 2 gives me the answer 2. So I have good solid points to put on my graph. It makes everything easier. The second one is the line y equals negative x. I did it totally wrong. Don't do it that way. This way, not that way. So negative x, we know, is a slope that goes down. I knew right away as soon as I did it, but it happens. Okay, so this way, negative 1 going down. The shaded area is what I'm looking for. To find the bounds, make them equal to each other. So I have x squared subtract 2 equals negative x, and then solve it. So I'm going to add x to keep the power term positive, and then solve it. So when I solve this, the two bounds are negative 2 and positive 1. And then it's top subtract bottom. So when this negative x, that's actually on the top. And then subtract the bottom, which is x squared minus 2. So in this question, it says find the area, not just integrate it. So I'm going to simplify this. So that's negative 2. So that gives me negative x squared, negative x. And when you subtract the negative, that's plus 2. Then I'm going to integrate this. So I'm going to add 1 to the exponent and divide. Same thing here. And 2 is 2x. And I'm integrating from negative 2 to 1. Then the last step is we're going to plug in 1. Subtract and plug in negative 2. And this would be that area. All right, turn the page. Find the average value. So to find average value, that's an integration question from 0 to 6. I'm going to write it friendly already. That's 2x plus 4 to the 1/2. And then I divide by the difference of the bounds. So 6 take away 0 is 6. I'm just going to write that as 1/6. And then I'm going to integrate this. So to integrate this, I need to see the hook. So the hook is 2. That's a dx, which means it was a 1, it became a 2. So this hook is not part of my answer. So I have 1/6, I have 1/2, and then I have 2x plus 4 to the add 1 to the exponent and divide from 0 to 6. On the side, if I go times the reciprocal, the 2's cross out, and it's really 1/3. So I'm just going to write it as 1/3. And then I'm going to plug in. So I'm going to plug in 6 first to the 3/2, subtract, then I'm going to plug in 0. So you could put 1/3 inside for both, or just factor it out, and that's 1/18 really, and you have your setup. Oh, it says show an integral setup only. What a bad reader I am. So the integral setup only would be this. The rest was just for fun. Let's try to read it. Set up, but don't integrate. All right, I'll be a listener. There we go. So sketch at the right, which I see, is this graph. That looks like a fun equation. Set up an integral for the volume revolving around the region bounded by x equals 0, x equals 1, y equals 0, and the curve. So this is what we're talking about. I'm going to fill it all in. And I'm going to revolve it around the x-axis. So if you look at the area and you fill it in, notice the area and the x-axis, there's no space. So there's one circle. So we're going to go pi. It goes from 0 to 1, and it's one circle, one radius. And so top subtract bottom is the curve, which is x to the fourth subtract root x plus 1. And the bottom is subtract 0, which I don't need to write down. And there it is to find the volume revolving around the x-axis. All right, next one I got a graph. It says a solid with square cross sections has a base region here. And it says show a sketch of this. You can do it. So I'm going to plug in 0, and then I get the answer 2. If I plug in 1, the square root of 1 is 1 plus 1. That actually gives me that answer, 1. If I plug in 4, because that makes more sense, right? The square root of 4 is 2 plus 1. That gives me 2/3. You get the idea of like where this graph is going as a curve. And x equals 3. That's here. And y equals -1. That's down here. X equals 0 is the y-axis. So if I shade in everything that's been trapped, this is what it would look like. And so it says, show and sketch and shade in the region. I did. Set up an integral that gives the volume of this if I'm using square cross sections. So if I go top subtract bottom here, that's the curve, which is 2 over the square root of x plus 1. Subtract the bottom, which is -1. That's top subtract bottom. So that becomes the base of my square. So I'm going to integrate from 0 to 3. And then the area for a square, that top subtract bottom is my base. So I'm going to use this formula and plug in that for the base. So it says just set up an integral. So I'm a good reader here. And there's the setup with square cross sections perpendicular to the x so that they're vertical. All right, last one here. What happens when you take the derivative and integrate? They cross out, right? It's a substitution question. We plug in the upper bound. When I plug in 5 and take the derivative at 0, if I plug in x, the t's all become x's. And then the hook, if I had one, would be the derivative of x, which is just 1. I don't even need to go times 1. And that's the answer. All right, I'm proud of you for finishing the review packet. I know you're going to do great. All right, so get rest, eat breakfast. I believe in you. And we'll go from there. I know you're going to do good. Mr. G Math, over now.